Okay, so we start with chapter 3, partial fractions. It's a continuation from our N5 partial fractions. So in N5, we dealt with simple examples compared to what we're going to deal with. This one here is not too bad also. Right, so now you can refer to your formula sheets if ever you forget how to split up your fractions. Okay, but you don't really need it once I show you how it's done. So now here we have a fraction. Okay, there's no number on the top there, obviously it is a positive one. So what we need to do now is we need to rewrite this. Forget about the integration. Integration will only be the last step. That's the easiest thing to do. Right? The long part is to actually work out all your fractions. So the fraction that we have here is 1 over x minus 3 all squared times x minus 1 all squared. So if you remember from your N5 work, how many fractions will we have? Okay, that will depend on the degree of the denominator. Right, so the denominator fourth degree. Now, how did I work that out? Fourth degree means the highest power of x. If you had to multiply out that denominator completely, what will the highest power of x be? So what do I mean? I mean you got x minus 3 all squared and then you have x minus 1 all squared. So when you square this, you're going to have x squared and you're going to have a few other terms here. Right? Then when you square this one, you're going to have x squared and you will have 2 more terms. These other 2 terms are not important in order to determine the degree. Right, so you look at the highest power here, highest power there, and you know we still have to multiply those 2. So when you multiply x squared times x squared, you get x to the power 4. So therefore the degree of the denominator is 4 degree. Okay, you can do this mentally. Obviously you know you're going to have x squared here, x squared. When you multiply, it will be x to the power 4. So if your denominator is 4th degree, then you're going to have 4 fractions, you're going to have 4 constants, a, b, c, and d. Okay, that's how you determine how many fractions you're going to have. It is determined by the degree of the denominator. Okay, so now, 4th degree, what does it mean? It means you're going to have 4 fractions. Okay, 4 fractions. So now, let's start with the first factor here. The first factor is x minus 3 all squared. So this is a square. So with this one, you're going to have 2 fractions, and with this one, you're going to have another 2 that will make up your 4 fractions. Okay. So how do we start? You can start by writing down a all over x minus 3 to the power 1 plus b all divided by x minus 3 all squared. Or if you want to, you can start with the square first and then drop down to the power 1. So how did I do that? If this was a power 3, then I'll have I can start with 1 and I go up to 3. Or I can start with 3 and come down to 1. Okay, the fact is, this is 2, you will start with 1 and then 2, so that will be a over x minus 3 to the power 1 plus b all over x minus 3 to the power 2. So now we are done with the first one. The second one here is x minus 1 all squared, so that will be plus c all over x minus 1 to the power 1 plus d all over x minus 1 all squared. So there are my 4 fractions now. Can you all see that? These are the 4 fractions. You don't really need to use your formula sheet here. You just need to check the degree of the denominator and then from there work it out. Now, what do we do next? What do we do next is to get rid of all the denominators. So what are we going to do now? We are going to find the values of a, b, c, d, and once we're done with that, then we're going to put it back. We're going to put back the integration sign and then start integrating each one. Okay, so now we need to get rid of all these denominators. So what am I going to do now? I am going to multiply both sides by the original factor, the original denominator on the left. Okay, basically what I'm going to do is find LCD on both sides and cancel the denominators. But it's going to take too long if we do it individually. So the quick way to do this is always multiply on both sides. Let me just copy this down again. So there's my left hand side there, x minus 3 all squared, x minus 1 all squared. So this is what we need to multiply both sides by. X minus 3 all squared, x minus 1 all squared. On the left hand side, and whatever I do on the left hand side, I must do on the right hand side. So that's a over x minus 3. I need to multiply this also by x minus 3 all squared times x minus 1 all squared. The next one there is plus b all divided by x minus 3 all squared. So we are multiplying by x minus 3 all squared, x minus 1 all squared. Okay. Then we have plus c all over x minus 1 multiplied again by x minus 3 all squared, x minus 1 all squared. And then finally, the last one there is plus d all over x minus 1 all squared. So we got x minus 3 all squared, x minus 1 all squared. Alright, it takes long to write this down, but there's nothing difficult about this here. Alright, so let's start cancelling now. So on the left hand side, this cancels, you can see. So we have 1. Then let's start on the right hand side. On the right hand side, x minus 3 will cancel with one of the x minus 3's on the top. So I'm going to have a times x minus 3 times x minus 1 all squared. Plus b, this will cancel, you can see that. So I'll end up with b times x minus 1 all squared. Then here I have plus c, x minus 1 will cancel with one of the x minus 1's on the top. So I have x minus 3 all squared times x minus 1 plus d, x minus 1 squared and x minus 1 all squared will cancel. Then you end up with x minus 3 all squared. Alright, so now we need to, there are two methods from here. Two methods we can use. One is to remove all the brackets here and use equating coefficients. We can do that. We will do it with a different example. Now I want to show you the method of substitution. Right. So in order to find A, B, C, and D, remember there are 4 fractions, 4th degree, 4 constants, A, B, C, D. That means there will be 4 substitutions. Everything will be 4. Okay. So what values do we substitute? We can substitute any 4 different values for x and then form 4 equations and then work it out. Okay. Now, we do not want 4 equations with 4 unknowns, A, B, C, D, A, B, C, and D. And then we will have to use determinants, Kramer's rule, to go and work that out. So we want to try and avoid that in the exam. We're going to try and get these A, B, C, D as fast as possible. So we will try and choose a value that will eliminate one of those constants, or eliminate 3 of them, and you can work out the formula. Now what do I mean by that? I mean that if I substitute x is equal to 3, that means 3 minus 3 will give me 0. So A will be eliminated. 3 minus 3 is 0. C will be eliminated. 3 minus 3 is 0. D will be eliminated. Then I will only be left with this one. And I can work out the value of B. Then after I'm done with that, my second substitution now. I'll go back always. This is the main one. This category. I can go back and substitute x is equal to 1. If I substitute x is equal to 1, A is eliminated again, B is eliminated, C is eliminated, but D will not be eliminated. I will be able to work out the value of D. So that's exactly what I'm going to do now. Right, so now let's start with this. Let me start with let x equal to 3. So if I let x equal to 3, then here I'm going to have, let me just do the actual substitution since this is the first example. So I've got a, 3 minus 3, 3 minus 1 all squared, b, that will be 3 minus 1 all squared, c, that will be 3 minus 3, 3 minus 1, plus d, 3 minus 3 all squared. So you can see the actual substitution. So on the left hand side I have 1, on the right hand side this is a 0, 3 minus 1 is 2, 2 squared is 4, so I got 4b, 3 minus 3 there, 0, 0 times anything is 0, 3 minus 3, 0, 0 squared is 0, 0 times anything is 0. You don't have to go and write all those down, but just for the first example that you can see. So now I have only b to work out. Can you see that? So 1 over 4 is equal to b. So I got that sorted. Okay. Now my next substitution, I can let x equal to 1 because 1 is going to give me a 0 for 3 of those terms. So now on the left hand side, remember on the left hand side we have 1. There's nothing to do with this one here. The one that was, this is the numerator. You can see that. So here we have a, and then we have now x minus 3, so that's going to be 1 minus 3, and then we have 1 minus 1 all squared plus b, then we have 1 minus 1 all squared there, plus c, this will be 1 minus 3 all squared, and then you have 1 minus 1, plus d, we have 1 minus 3 all squared. So now 1 is equal to, wherever you have 1 minus 1, you know it's going to be 0. 0 times anything is 0. That's a 0 there, 0 there, 0 there. And only this one we can work out. 1 minus 3 is minus 2. Minus 2 squared is 4d. Alright. So now 1 over 4 is equal to d. So we got b, we got d. Now, there is no other value that we can substitute that will get us c and a in one step, like what we have done. So we can substitute now any value we want to. We will end up with simultaneous equations, but at least we have only 2 unknowns, which is easy to work out. Right, so let's do a substitution. Choose an easy value that you're not going to take too long to type up. Choose 0. So I can say let x equal to 0. 0 is an easy substitution. So on the left hand side, I got 1 there. This is a, that's 0 minus 3, 0 minus 1 all squared, plus b, 0 minus 1 all squared, plus c, 0 minus 3 all squared is 0 minus 1, plus d, 0 minus 3 all squared. Right. So now 1 is equal to. So now here, I'm going to do this mentally. You can always double check with it. Right. So here, we got 0 minus 1 is minus 1. Minus 1 squared is 1. 1 times minus 3 is minus 3. So that's going to be minus 3a. Right. Here, minus 1 squared is 1. So that will be plus b. This is going to be minus 3 squared, which is 9. 9 times minus 1 is minus 9. And times c is minus 9c. Okay. See what's happening there? So 0 minus 3 is minus 3. Minus 3 squared is 9. So that's plus 9d. Alright, so now what do we already know? We know the value of d and we know the value of b. So let's substitute it. Right, so what is b? b is 1 over 4 and d is also 1 over 4. And then we now can make our equation in terms of a and c. Right, so let's see what is going to happen over here. We got 9 over 4 plus 1 over 4, which is 10 over 4. And then we got 1 here, so let me just see what's going to happen up here. So that's 10 over 4 minus, it will be minus 6 over 4 is equal to minus 3a minus 9c. You can just double check me on the calculator there fast. So what I have done here now, I've just isolated, I've kept minus 3a minus 9c on the right hand side, and I'm taking everything else to the left hand side. Okay, whoever's fast on the calculator, do it now. Okay, before I move on. What am I going to do next now? Okay. So your calculator obviously might show you minus 3 over 2 is equal to minus 3a minus 9c. Is that correct? Yes, okay. So now, this is our equation. Let's call this equation 1. There's nothing we can do here at the moment. There are two unknowns. Can you see that? We need another equation, so we need one more substitution. I chose x is equal to 0, x is equal to 1, x is equal to 3. Let's see if there's anything easy. What else can we substitute? We chose 1, 0, 3. Let me choose 2 this time. Remember, you can choose any value you want to. Okay, any value, but you must not repeat the values, otherwise you're going to get the same result. So I'm going let x equal to 2. So if I let x equal to 2 now, on the left hand side, 1 is equal to a. So that's 2 minus 3. Okay, let me just do the whole thing here. So that'll be 2 minus 3, 2 minus 1 all squared, plus b. This will be 2 minus 1 all squared, plus c, 2 minus 3 all squared, times 2 minus 1. Then we got plus d, 2 minus 3 all squared. Okay, so now 2 minus 1 is 1, 1 squared is 1, 2 minus 3 is minus 1, so that will be minus 3. Here, 2 minus 1 is 1, 1 squared is 1, so that will be plus b. Here, 2 minus 3 is minus 1, minus 1 squared is 1, 2 minus 1 is 1, so 1 times 1 is 1, so that will be a plus c. Here, 2 minus 3 is minus 1 squared is still positive 1 times d, that will be plus d. So again, what do we know? We know the values of b and d. So what is the value of b and what is the value of d? They are both 1 over 4. Alright, so we got 1 over 4 plus 1 over 4, which is 2 over 4, which is 1 over 2. So 1 minus half will give me half, so I'm going to get half on the left hand side. That's going to be minus a plus c. Double check the fast person on the calculator. Correct. Right, so now we have simultaneous equations here. Okay. We have simultaneous equations with two unknowns. It's up to you how you're going to work this out. Right. So let me just try and work it out here quickly. You can use the method of elimination. You can use substitution. You can use determinants, Kramer's rule, as long as you get those constants correct. Alright, so I'm going to do it by, let me see now, what I can do here is with this equation, I can divide this equation by, let me divide it by 3. Okay, now you don't focus on what I am doing over here, I'm just working on simultaneous equations. You need to make sure that you understand all the substitutions, why I substituted these values, why did I start with 3. Okay, I could have started with 1, it didn't make a difference, 1 or 3. Right, so you focus on that. So what am I going to do now? I'm going to divide by, let me divide by 3. So if I divide by 3, I'm going to have minus 1 over 2 is equal to minus a. I and that will be minus 3c. That is my equation 1 there. Then in the bottom, I got 1 over 2 is equal to minus a plus c. Now why did I do this? I want to use the method of elimination. I want to make the coefficients of one of these the same. So in the next step, I'm going to subtract. I'm going to go top minus bottom. So if I go top minus bottom, when I say top minus bottom, minus a minus minus a. Top is minus a minus minus a. So it becomes minus a plus a, which is 0a, which is 0, and that is elimination. A has been eliminated. Right, I'm just going to do this mentally now. But that's going to be a 0. Minus 3c minus c is minus 4c. Minus half is going to be minus 1. So therefore, 1 over 4 is equal to c. It seems like everything is going to be 1 over 4 here. Alright, so c is equal to 1 over 4. Now, what else do I need to find? Just a. I'm not going to use elimination again. Alright, y'all can use the calculator. Check on your calculator. Put this, the advanced calculator that can do this one time. Alright. Okay, hold on. Let me just work out a first. Right. Let me just work out a first and then we'll check. Right. So I got c is equal to 1 over 4. So I got 1 over 2 is equal to minus a plus 1 over 4. So therefore, a is equal to 1 over 4 minus 1 over 2. So that will be 2 over 4. So 1 minus 2 is minus 1 over 4. So I got a equals to minus 1 over 4. Alright, so let me just double check this on the advanced calculator. I'm going to erase the board now. So let me just. Alright, so now. So what have I done now? I found my a, b, c, d, and I put it back. Remember, a over x minus 3, b over x minus 3 all squared. Substituted it. So now I need to integrate. Okay. So let me put in my integration sign. So I need to integrate 1 over x minus 3 all squared times x minus 1 all squared dx. So here I'm going to integrate. So now it's best to take your constant and write it in front of your integration sign, like this here. Minus 1 over 4, so you end up with just 1 over x minus 3. Okay, here plus 1 over 4. And then I'm going to end up with 1 over x minus 3 all squared. Here, plus 1 over 4, and that will be 1 over x minus 1 squared. And just x minus 1, okay. Plus 1 over 4, and that's 1 over x minus 1 all squared. Right, so now it's the integration part, which is the last part. So it's always the N5 work we go back to. So I'm going to integrate by inspection. Okay, at this stage, you would have been familiar with all your integration. You can recognize whether this is a type A or type B. Right, this is type B. Okay, basically a type where the numerator is an exact derivative of the denominator. Here, this is not. So what I need to do, I cannot integrate. This is not in standard form. This is not in standard form. So let me just rearrange again. Term 2, you must take this to the top because it's not the same as term 1. So that becomes a minus 2. Can you see that? Term 3, you leave it as it is because the numerator is a derivative of the denominator. Term 4, you need to take this to the top. So that's going to be x minus 1 to the power minus 2. Okay, so we are dealing with these two types here. F prime x all divided by f of x dx is going to equal to k ln absolute value of f of x plus c. This applies to term 1, term 3. Then term 2 and term 4, we are dealing with f of x to the power n times f prime x, okay, which is equal to k f of x to the power n plus 1 all over n plus 1 plus c. The first two types come up in 5. Okay, so I'm going to do this by inspection because the coefficient of x is just a positive 1, and even that will be straightforward to integrate. That's going to be minus 1 over 4 ln absolute value of x minus 3 here plus 1 over 4 x minus 3 minus 2 plus 1 is minus 1 over minus 1. Remember, I'm going for n plus 1, 10 plus 1. Here plus 1 over 4 ln absolute value of x minus 1. Here plus 1 over 4 x minus 1 minus 2 plus 1 is minus 1 plus c. That's the easy part for integration. Okay, so that will be minus 1 over 4 ln of x minus 3, and that becomes minus 1 over 4. Just simplify now. The job is done, so I'm just doing the simplification. And we're done. That's a 6 marks. Right, we continue. Well, I'm going to be dealing with more examples with the next class. Right, so our next example here, number 9 of exercise 3.1. So here again we have a fraction where clearly the numerator is of a lower degree than the denominator. So now, the previous example, okay, that I just did, the degree of the denominator was 4. Okay, the numerator, you just had the number 1. Now you have basically x's in the numerator and the denominator. So now, in order for you to apply partial fractions, the numerator must be of a lower degree than the denominator. Okay, which I did not mention with the first example, but it applies everywhere. In order for you to apply partial fractions, the numerator must be of a lower degree than the denominator. So now, let's determine the degree of the numerator. So in order to determine the degree, all you do is read of what is the highest power of x in the top. Clearly, it is 2. Right. What is the highest power of x in the denominator? Now this is not clear because there's brackets there. Now, can you see that? So you mentally, if you remove the brackets, you're not worried about every single term. All you're doing is remember that if you square the first one, you're going to get an x squared. You're not even worried about the 2 squared is 4. That's not important. What's important is that the x is being squared, so you're going to end up with x squared times the x, which is going to give you x to the power 3. That's the point of interest. There is the highest power of x. So the denominator, third degree. Numerator, second degree. So it satisfies the condition. What is the condition? The top must be smaller than the bottom. That's basically what it is. The numerator must be of a lower degree than the denominator. In other words, it must be a proper fraction. Okay, a proper fraction is when the top is smaller than the bottom. Now, we got that sorted out. So, now how do we rewrite? How do we take this single fraction? So let's copy it down. 4x squared minus 12x minus 2 when we got 2x plus 3 all squared times x minus 1. Now, third degree, the denominator is third degree. That means you're going to end up with 3 fractions. You're going to have a, b, and c. 3 constants. So, let's start with this one here. So, this is equal to a all over. I will start, there's a power 2, but you always start with 1, or you can start with 2 and come down to 1. It means the same thing. So, I'm starting with 1 plus b all divided by 2x plus 3 all squared. So we are done with 2x plus 3. We move on to the next factor then, which is x minus 1 plus c all over x minus 1. So that is the beginning. It must be 100%. Okay. Now it's just the method. What are we going to do? We are going to multiply by, basically we're going to get the LCD here. So fast way is to multiply by this denominator throughout, so all the denominators will be cancelled. Okay, so that's exactly what I'm going to do next. Alright, so I'm just going to copy this down. Right, so I'm going to multiply by 2, this will be 2x plus 3 all squared times x minus 1 on the left hand side, and then 2x plus 3 all squared times x minus 1. This will be 2x plus 3 all squared times x minus 1 again. 2x plus 3 all squared times x minus 1. If you do many examples, then you can even skip this step because you will be able to cancel mentally. Okay, it will speed you up. Right, but for now, you need to see exactly what's going on. So what's going on is now that and that must cancel, so you end up with 4x squared minus 12x minus 2. Here, 2x plus 3 will cancel with 2x plus 3, so I end up with just a times 2x plus 3 times x minus 1. Here, 2x plus 3 all squared will cancel one time there, and you end up with b times x minus 1. X minus 1 will cancel there, so that will be plus c times 2x plus 3 all squared. Now follow what happened there? Okay, just simple cancelling. Now, the method of substitution. Okay, the method of substitution is what I just did previously. Okay, I'm just thinking of once I show you the other method now. Okay, let me do the substitution again. Okay, then we can always do it in a different way. So now, I need to substitute values. What values do I substitute? I need to substitute 3 values here because there's 1, 2, 3 unknowns here, A, B, and C. Now, I can substitute any 3 values I feel like, but I need to think now which value can I substitute that will get me to the solution faster than any other value. Alright, so what do we do? Okay. If I substitute x is equal to 1, okay, why am I saying 1? Because if I put 1 here, 1 minus 1 will give me 0. 0 times this whole thing is 0. A is eliminated. 1 minus 1 is 0. 0 times anything is 0. B is eliminated. And 2 times 1 is 2 plus 3 is 5. I can square that. And then I will have C alone there. And then I can work it out. Then I'll work out C. You follow? Then the next one. What can I substitute? What will make this one 0? And you'll see now. So let's start. Let x equal to 1. So I'm going to do it again in detail here. So wherever I see x, I'm going to replace it with 1. Again, once you know your work properly, this is an unnecessary step, what I'm doing. You can do the substitution mentally and just write down what you get. All I'm doing is replacing x with 1. Right, so now, what do we have here? 4 minus 12 is minus 8, minus 2, which is minus 10, correct? Here, you know that 1 minus, wherever you got the 1 minus 1, wherever you got the 0, you know it's going to be 0. This one is going to be 0. This 2 plus 3 is 5, 5 squared is 25. 25 times c is 25c. Now, solve for c. Minus 10 divided by 25 is equal to c. That's sorted. My next substitution. Now my next substitution, again, I want to try and make it easier and faster to work out. So therefore, is it possible for me to substitute? Look at the other factor now. We're done with the x minus 1. You've substituted 1, you got 0. Now, is there a value that I can substitute that will result in this whole thing becoming 0? Yes, there is. All you do is, on the side of your page, what do you want? You want 2x plus 3 to become 0. You see, from words to equation. Right. You want 2x plus 3 to equal to 0. So the question is, what value of x can you substitute? You just solve for x. So now, 2x is equal to minus 3, x is equal to minus 3 over 2. So the next best value to substitute here is minus 3 over 2. So let's do that. Left-hand side. Let's start on the left-hand side there. So that's going to be 4 times minus 3 over 2 squared minus 12 times minus 3 over 2 minus 2 is equal to a, and that's 2 times minus 3 over 2 plus 3, and then we got minus 3 over 2 minus 1 plus b, and that's minus 3 over 2 minus 1. Then we got plus c. That's 2 times minus 3 over 2 plus 3 all squared. Okay, so do this on the calculator there fast. Give me the answer. The left hand side. Whoever's fast, I want the answer in a few seconds. So we can deal with the right hand side. $25. Am I right? Okay, this should be 25. Right, so it's 25 on the left hand side. Okay, on the right hand side, wherever I have the 2x plus 3, you know it's going to equal to 0. So you know this is going to be 0. The whole idea was minus 3 over 2. So all you have to do is look here. That's going to be 0. That's going to be 0. So it's pointless going and working on anything. That's going to be a 0. That's going to be a 0. This is what we need to work out. Minus 3 over 2, minus 2 over 2 is minus 5 over 2. Okay. So now, what are we going to get now? So 25 divided by minus 5 over 2 is equal to d. So we should get that will be 50 divided by minus 5, which is minus 10, correct? Minus 10. So b is equal to minus 10. Obviously, all this you need to double check it, make sure there's no small error there. So b is equal to minus 10. Now, we ran out of values that will get us to the solution fast. So now, we can substitute any other value for x, because we already know the values of b and c. So if we substitute for B or C, we can now work out the value for A. Right, but we need to substitute a value for X. So choose an easy value. Let's choose 0. 0 is an easy value to substitute. So now, on the left-hand side, I've got 4x squared. Wherever there's an x, you know it's going to be a 0. So that's a 0 there, left-hand side, minus 2. Alright, so here, you know it's going to be a 0 here, 0 here. So 3 times minus 1 is minus 3, so that becomes minus 3a. You know this is going to be a 0, so minus 1 times b, minus b. You know this is going to be a 0, so 3 squared is 9, 9 times c is 9c. You saw how fast that was? Okay, you could have done it for the previous example, so instead of going and actually writing down everything, but only once you know it properly. So now, I know that b is minus 10. Let's substitute and work it out. So that's minus 2 is equal to minus 3a minus 10 plus 9 times c. What was c? Minus 10 over 25. So I got 3a is going to equal to, if I take this to the right hand side, it's going to be a 2 plus 10, and then we're going to get minus 90 over 25. Correct? So 3a is equal to 12 minus 90 over 25. What do we get? 80 over 25. Let's double check me on the right hand side. We got 180 over 25. What is it? Positive. Okay, let's give me the right hand side there quickly. 12 minus 90 over 25. Can't hear you. 42 over 5. So that's 42 over 5. Everyone gets the same thing there? So therefore, A is going to equal to 42 over 15. So now, what am I going to do next now? I worked out my A, B, and C. So now I'm going to substitute here. And then I'm going to integrate. So let me just give you 2 minutes to just absorb what just happened there. Right, so we found our A, B, and C. Now, we copy down. Remember it was A over 2x plus 3, B over 2x plus 3 all squared, C all over x minus 1. We found our A, B, and C. Substitute. What was my A? My A was 42 over 15. My B was minus 10. And then my C over C minus 10 over 25. Right, so now this is integration N5. What do we do? How do we deal with this here? Right, so most of the time we're going to end up with this type or that type. Right, so this is, I call it type B. This is where the numerator is an exact derivative of the denominator. Right, this is multiplication, this is division. Multiplication, you got f of x multiplied by f prime x. So whatever the power is, it doesn't, as long as your power is not equal to minus 1. Then you can apply this. You're going to see now in a few seconds. So what must you do if you want to integrate? Get everything in order. Write it down properly. So if you have a constant, write down your constant on the left of your integration side. So write it as 1 over 2x plus 3. Okay. Now we can see f prime x, f of x. Right. Why? Here this is this typing. You must be able to recognize this one. Okay, let's take the negative 10 multiplied by 1, so that's minus 10. This is not the same as the first one. This you must take to the top. So that will be 2x plus 3 to the power minus 2. This one, okay, positive times negative, so it will be minus 10 over 25. And this becomes 1 over x minus 1, which you will leave in the denominator. Okay, now we need to integrate. Okay, so term 1 and term 3. Let me start with this one here. If you didn't understand integration before, you better be watching now. Right. This is type B, your fraction, where the numerator is an exact derivative of the denominator. So what is the exact derivative of x? It's 1. So therefore, I can go straight in one step and write down my answer. So this is going to be minus 10 over 25 ln absolute value of the denominator plus c. You're clear with that? Now, let's go to the same thing now. Same concept, it's just that it's not x minus 1, it's 2x plus 3. Now, okay, so here now, what is the exact derivative of 2x plus 3? It's 2, right? Do you see 2 on the top there? No. So if I put a 2 on the top, I must divide by 2 in the bottom, because what is 2 divided by 2? 1. I'm not changing the question in any way. That's how you use inspection now. This is integration by inspection. So if I write down a 2 there, I must divide by 2 to cancel it out. So basically, if I'm dividing by 2, I'm actually multiplying by 1 over 2. So now, watch how this is done now. Now this whole thing here is your k value there. There's f prime x, there's f of x. So this is actually 42 times 1 over 2 ln. Remember, it's always k ln of the denominator. So that's ln of your denominator here, which is 2x plus 3. So that's done now. That is the method of inspection. Okay, obviously you're going to work this one out. Now, what about this one? Let me show you now what's happening. Let's say we had an example like this here. We had something like x plus 2 to the power minus 2. This is the first type here. So I can integrate this in one step. It's going to be x plus 2, n plus 1, n plus 1. So that's going to be minus 2 plus 1 is minus 1, over minus 1 plus c. Why could I do this? Because I had an exact derivative, f of x, f prime x. What is the derivative of x plus 2? It's just one, exact derivative. Can you see that? But it is not the case over here. What is the derivative of 2x plus 3? It's 2. Do you see 2 there? No. So you create that situation. You write down the 2 there and you divide by 2 there. So now what do we have? We have f of x, f prime x, and there's your k. Remember, this is 1 over 2. You're clear with that? Right, so now this is going to be minus 10 over 2, and then you're going to go 2x plus 3, minus 2 plus 1 is minus 1, minus 1, we're done. That's our integration. Now I'm just going to simplify my answer. So this is going to be 42 there, that's going to be 21 over 15 ln of 2x plus 3, and this is going to be plus 5 all over 2x plus 3. I'm just taking this to the bottom. 10 divided by 2 is 5. Negative divided by negative, positive. Here, minus 10 over 25 ln x minus 1 plus c. And that was the method of inspection. Once you know inspection, everything starts becoming easy. Okay, so that will be all for now.